Day 3 of Module 11 with circles. We're going to really focus on the angles part. So our learning target is to find a measure of angles formed by lines crossing in a circle. And so we're going to identify those angle measurements when those lines are crossing within and without the circle. That's our learning target here. So a couple vocab words just to make sure we are good with. Remember, a radius is from the center to the outside. So like this would be like AF. So we're going from here to the outside. That would be one. You could also do AH would also be considered a radius as well. A chord is just a line that cuts through and ends on the circle. So like DG would be a chord because it just stops and doesn't keep going. That's what we consider to be a chord. A tangent line is a line that hits the circle one time and keeps going. So this would be the line like BJ. And I'm going to put these arrows on the end, which means it's going to keep on rolling through there. So that would be one of those, that this line right here that's touching one time and keeps on going. The point of tangency is where it touches the circle at. So this would be point H. Right here would be that. A diameter is the longest chord, but also it is a line segment that cuts through the center and hits the end. So this would be like HF right there. So from H to F, or you can name it FH, either way. And then a secant is a line that cuts through the circle that keeps on going. So it's a lot like a chord, but it keeps going. So this would be like the line BD. And again, we're going to put these arrows that denote that it's going to keep on going from that. That's a secant. So again, radius is from the center to the outside. A chord is a line segment that has both endpoints on the circle. Tangent is a line that keeps going that intersects the circle at one spot. And that point is the point of tangency. The diameter is cuts through the center and has its endpoints on the circle. And then a secant is a line that goes through the circle and keeps going. Okay, so the longest chord in a circle, again, that's going to be a diameter because it stops and keeps going. And then within this, we're going to have lines that cross, and we're going to have we have some different theorems about the angles that are formed with those lines. Okay, so when we have two radiuses that intersect, okay, so for example, if I have those two right there, they go through the center here, they form this angle right here, and that angle is going to be equal to the arc rotation. So it's the rotation of the arc for that. So again, this middle angle is what we call the central angle. Okay. And it's going to be measured by a degree or a radian. That is going to be equal to the rotation of the intercepted arc. So again, if I had a bigger picture here, this angle right here and this arc that's rotated through here would be the same. Okay? So again, if this was, let's just say this is 80 degrees, we would say that this is rotated from here to here 80 degrees as well. So the central angle is going to be the same as the intercepted arc between those two. Okay? All right. My inscribed angle is two chords. So we're going to have two chords that form this. So I've got a chord that goes here and a chord that goes right here. This is my inscribed angle, okay? And it's going to have an intercepted arc as well. So the inscribed angle, this is the theorem or the rule, that is going to be equal to 1/2 of the rotation of the intercepted arc. Okay, so again, if I have my circle here, and I've got my inscribed angle here, that's right here. Let's say that this arc here that's rotated by is 80. That means that this is 40, is what that is. And the unique thing about this is this angle is going to be half of the central angle as well. So if we kept the rotation the same on the arc and put this point in the center, it'd be 80. So the central angle is going to be equal to the arc, but the inscribed angle is going to be half of that arc. Okay? These two are pretty important to remember. Third one is a circumscribed angle. Okay, so a circumscribed angle is going to be made up of two tangent lines. Okay, so we're going to have these tangent lines here that again touch one spot. This is the inscribed angle. Okay, and this is compared to the central angle. So this outside angle and this inside angle are going to be supplementary to each other. Okay, so what that means again is the circumscribed angle plus the central angle are going to be equal to 180 degrees. Okay? All right, so we just want to be able to apply those three rules within these circles. So these should be pretty quick rules that we have here. So all I've got to do is identify whether it's a central inscribed or a circumscribed angle. So if I look at this first bit, the angle that I'm given right here, this is a circumscribed angle. This one's an inscribed angle. Again, this one right here, again, same thing. This is an inscribed angle. It's made up of two chords. Okay, this angle is a central angle because it's with two radiuses. Two tangent lines here would be circumscribed, and two radiuses would be central. Okay, so you should be able to identify all of those as well. Okay, all right. Next part here wants you to use your rules and find the actual measurements of either an arc or an angle. Okay, so this is an inscribed angle, so this angle is going to be half of the arc that's from here to here. So all I do is go 102 and divide it by 2, and that would give me 51. Okay, so you got to identify whether it's an inscribed, central, or circumscribed, and then you just use the rules here. Okay. This one again is an inscribed angle, so this angle's half of that arc, but I don't know the arc, so it's double. So I go 23 times 2, and that would give me 46, and that would be what that angle would be. Okay, if I look at this one, I've got two inscribed angles, so I've got this one that has a 42 rotational arc, so this is going to be half. So 42 divided by 2 would give me 21, so y is going to be equal to 21. And then for x, this is a 90 degree, so this should be double of that. Again, 90 times 2. So I'd have x is equal to 180 for that. So just applying those rules that you see. Okay, this angle right here is represented by 2x plus 6. And the arc, if you get rid of it, the arc is this that's a diameter, so this would be 180. So this angle should be half of that. So 2x plus 6 should equal 90 because it's half of that. And then I just solve that. So minus a 6, minus a 6. So to have 2x equals 84. Then divide by 2, divide by 2. And so I'd have x equals 242. Okay, these two, again, same idea. These are inscribed angles. If you notice, though, they cover the same arc on both of them. So whatever these two angles are, they should be equal to each other. So 3x plus 7 should equal 6x minus 11. And then I just get like terms together, so minus 3x. That would give me 3x here. I can plus 11. And that would give me 18. Divide by 3. And I'm going to get x is equal to 6. And then you can find out what those angle measurements are as well. Okay. This one's got a little bit more lines than we need. We don't need to worry about those lines at all. I just need to look at these. This arc is going to be twice as big, or this is half of that. So I need 2 of these to equal that one. So this would be, again, 2 times 3x plus 25 equals 5x plus 60. So I distribute this 2 through, which would give me 6x plus 50. Then I would minus the 5x. That gives me 1x, and then I'd minus the 50. And that would give me 10. So x would be equal to 10. Okay, last couple here, just to keep with this, just looking at different things. So I've got circle W over here, and it has arc, and I'm going to label these as we go. So I have arc XZ as 60 degrees, so that's rotated 60. Again, we're talking about rotations, not like measurements. And then I have angle V, again, VWZ as 40. And then I know this is a diameter, okay? So before I even answer any of these questions, I'm just going to fill in this here. So this is a diameter, which means that's half of a circle, which half of a circle is 180. So 180 minus 60 will give me this 120 from this other side, okay? And then I've got 40 with these 2 chords. If I get rid of those, this arc over here should be double of that. So double of 40 is 80. So from Z to V should be 80. And then I can finish my 180 by going 100 from V to Y. So that gets me all my arcs, everything on the outside, okay? Now I need to finish angles on the inside, so I'm going to look at just central angles. So this central angle would be right here at XWZ, so that should be equal because central angles are equal. Again, ZWV should be the same as its arc, so 80 there. VWY should be the same as its arc there, so 100 there. Let me write that a little bit better. And YWX should be the same as its one, so 120 there. So I have all the central angles now. Let's take care of any inscribed angles. So I have another inscribed angle right here with 2 chords. That's going to be half of the arc. The arc that it is 60, so this would be half of 60, which would be 30. And then I have another chord right here at angle Z. So see, I have 2 chords. I have another angle that's an inscribed angle there. So that should be half of its arc, which is 100. So that would be half of 100, which is 50. That gives me those angles. And then the last thing, I've got a bunch of triangles that can find these others. So remember, the inside angles of a triangle add up to 180. So I just go 180 minus 100 minus a 40, and that would give me 40 for this angle. For this one, I can go 180 minus 80 minus 50, which would give me, again, 50 for this one. And then 180 minus 20 minus 30, which would give me 30 for that one. So I found all the angles that are within just using my central angle, my inscribed angle, and then the fact that half a circle is 180. I can just go over here and answer these questions, okay? So XWZ is 60. That's all I've got to do now is just look and write. YW, which that would be that 30. XWY, which would be 120. The arc XY would also be 120. The arc V to Z would be 80. Angle Y, V, Z. So again, Y, V, Z is this whole thing, those two added together. So that would be 90 because 40 plus 50 is 90. The arc V, Z, Y is 50. Or sorry, the angle, not the arc. The angle V, Z, Y. And then arc V, Y is 100. So once you have them all, you just got to look and go. So it goes pretty quick. And then our last set here is using the inscribed angle theorem. If you guys remember that the inscribed angle and the central angle add up to 180. So this question mark plus 117 should equal 180. So to find that question mark, right, all I do is minus the 117. And that will give me my answer from there. So hopefully you guys are good with that. So that should give me, again, 63 should be that angle. Okay, again, same thing here. This is the question mark plus 40 should give me 180. So I can minus the 40. And my question mark is going to give me 140. And then here, again, question mark plus 59 should give me 180. So I'm going to minus the 59, minus the 59, and my question mark should be 121 for that. And that's just using that simple rule as well. So, all right, that should be it for all your angles within your circles. We'll see you. Bye.